We want to graph this quadratic function here. So first of all, let's recognize that it's quadratic. We know that it's quadratic because we have the highest degree here is the squared term. So it's x squared is the highest degree term. So this is quadratic. Because it's quadratic, we know its graph should look like a parabola. And since a is positive, we know that the parabola is going to open upwards. If a was negative, this would be a downwards opening parabola. The most important part of the parabola is the vertex. That's the middle. That's the balance point. That's where we get the symmetry around. So the first thing we want to calculate is the vertex. So to find the vertex, you simply do negative b over 2a. And to find the y-coordinate of the vertex, you simply take that number and plug it in for x into the function. Alright, so a here is 2, the coefficient of the quadratic term, and b here is negative 4, the coefficient of the linear term. So let's start out by calculating the negative b over 2a part. So negative b means the opposite sign of b, so that's going to be positive 4 over 2 times 2. Now, if you plug this in your calculator at some point, be careful, because if you plug it in as is, the answer you're going to get out is actually 4 and not the answer that we actually get when you do this, which is 2 times 2 is 4, 4 divided by 4 is 1. Be careful plugging things in your calculators with negative b over 2a. So the x-coordinate of the vertex is 1. So to find the y-coordinate of the vertex, I simply take this 1 and plug it into the function for x above. So I'm going to plug in 1 for all the x's. So 2 times 1 squared minus 4 times 1 minus 1. And that equals, let's see, 1 squared is 1 times 2 is 2. Minus 4 minus 1, and that's going to equal 2 minus 4 is negative 2, minus 1 is negative 3. So we know that the vertex of this parabola is going to be 1, negative 3. So now we're going to make a table of values to graph this parabola. Remember, to accurately graph a parabola, you really should graph 5 points. So we're going to use the symmetry of a parabola to help us here. So we're going to put the vertex in the middle. And now, as long as I go from this x in each direction by the same amount, so for instance, go up by 1 and go down by 1, because of the symmetry of a parabola, these two y-coordinates are going to end up the same. So I can plug in either 0 or 2, and I'll get the same y-coordinates here. So between 0 and 2, I'll choose 0 to plug in because that's just going to give me the y-intercept, and we know that this right here is the y-intercept. So plug in 0, you get nothing here, nothing here. The only thing left is negative 1. So that's the y-intercept, and that's what you get when you plug in 0. So if this is negative 1, this is negative 1. That's symmetry. So then move another away, so I'll go 3, and then I'll go this way, I'll go negative 1. So now I have the choice to plug in 3 or negative 1. The choice is mine. And again, their y-coordinates will be the same because of the symmetry. So I'm going to plug in 3 for x just because I'd like to avoid the negative, because there tends to be more chance for an error with a negative than there is with a positive number. So plug in 3 for x. 3 squared is 9 times 2 is 18. 4 times 3 is 12, so minus 12 minus 1. 18 minus 12 is 6, minus 1 is 5. So this is 5 down here. And because of symmetry, this is 5. So now I just got to plot these points. So I have negative 1, 5, which is right here. 0, negative 1, which is right here. Now the vertex, 1, negative 3. And here comes the symmetry. And that, now I just have to play connect the dots and make a parabola. Make sure you curve it. I think I whiffed right there. Let me try that one again. I think I can make a better parabola than that. Alright, let's try again. Starting here, make my parabola. That's a little better. And don't forget to put your arrows on the end because it goes on forever. Now, you notice that right down the middle here is the balance point of this parabola. So this isn't really part of the graph, but remember, that's called the axis of symmetry. The axis of symmetry. That's where the line of symmetry is for this parabola. It's the line of symmetry. And since it's a vertical line, we know its equation is x equals, well, x equals what? What x coordinate does it go through? 1. which is the same number as the x-coordinate of the vertex. And this always happens. They match up because the axis of symmetry goes right through the vertex. So there's a look at graphing quadratic functions.